So, you want to learn about space, do ya?
Perfect! Because I have all of these random space facts accumulating here, and I have been dying for an excuse to info dump to somebody about it. It can be a little hard to find a place to start learning about astronomy, though. The tricky thing about learning about the universe is, well, for one, there's so much of it. Where do you find a place to start in all of this? Heck, I mean, most people just start from that fact alone, that space is so unbelievably huge.
Things in space are very far apart.
What do you mean?
I mean, very far apart.
But simply knowing that space is huge doesn't exactly help you learn about it. So I think the best place to start learning about astronomy is starting to learn about the universal truth. This one piece of logic that is behind the entire field of astronomy. When you're learning about space, there is one general assumption you make above all others. If it's true down here, then it's true up there. Now what I mean by that is, lightning on Jupiter is a thing. But lightning on Jupiter isn't that different from lightning on Earth. It works the same way. It's still an electrical discharge that's caused by particles in the atmosphere. It still works that same way. Granted, it forms a bit differently and it behaves a little bit differently, but it's still, in the end, just lightning. It's still the same natural physical process. And it's not just lightning either. Gravity on the moon is still gravity. Wind erosion on Mars is still wind erosion. The atomic hydrogen in the sun's core is no different from atomic hydrogen found literally anywhere else. It's all the same. This is the basic principle of astronomy, that the laws of physics, which we can observe on Earth, are identical and at work everywhere in the universe, just the same. Now, why is it important to know this? Well, you may remember the scientific method, that elegant 5-step process by which a prospective scientist might make observations of, experiment on, and deduce the nature of the world around them. But here's where we get back into that ever so popular fact that people always like to toss out.
Space is a big, empty place.
Space is big.
Really big.
Enormously, bigly huge.
All right, already.
So how can we do our science when the thing we're trying to science is way over there? And what if we don't have $1 million spacecraft flying around to do that? Since the invention of the telescope, all astronomers have relied on this universal fact to give us a frame of reference to work from whenever we make observations and make deductions. I'll give you a great example of how this works. Let's suppose it's 1994. You point your big fancy telescope in the direction of the constellation Pegasus. You spot this sun-like star, which seems to be wobbling in place for some reason. It's going back and forth, around and around, in a very particular pattern. It's repeating the exact same motion. This is especially odd considering stars don't normally wobble like this. So, what could this be caused by? Well, you obviously can't go to the star. It's, like 50 plus light years away. So you'd definitely be dead if you ever tried to attempt that journey. But you know how light behaves on Earth. You know about this thing called the Doppler effect, which can be experimented on Earth. And you also know about how gravity works. You know how gravitational forces can affect celestial bodies, both in orbit and in general. So you do some more observations of the star, and using what you know about the Doppler effect, you find that the star isn't merely wobbling, it's actually moving back and forth. Now, you know that the star is roughly comparable to the sun, and by observing how much it's wobbling, how much it's moving back and forth, you can make a deduction of how much the star is being moved by. And thus, you can also make an inference of how much force would be needed to move that object. Now, you know from gravitational studies that you can do on Earth or locally to Earth, as the moon orbits the Earth also wobbles slightly by being pulled by the moon. So you do the further observations of the star, you deduce that based on how far it's moving, the amount of mass that would be needed to create this kind of wobble would be on the order of a Jupiter-sized body. Hey, yo, wait, Jupiter-sized? That puts it squarely in the size of planets. So have we just discovered a planet orbiting another star? This wobble is caused by an alien planet. And that is how you discover one of the first extrasolar planets known to science. This is Bellerophon, which orbits the star 51 Pegasi. So hopefully this gives you some insight into how astronomy is done. You make observations, compare the results to things that you can study and experiment on Earth, and then draw conclusions from those comparisons. And that's roughly, I mean, it's not quite as simplistic as I laid out. There's many, many other things in the meantime. But that's how we learned about things like Saturn's rings, the surface of Venus, the teddy bear craters on Mercury, and many, many, many more things. But yeah, that's the basics for astronomy. I'll probably make more videos like this later on, but this is the starting ramble. So yeah, let me know how you like this. Let me know if you have any further questions on it. Suggest topics for me to ramble on. And yeah, bye.